Okay, good morning, boys and girls. We are going to review multiplication today. And we're going to be learning a new strategy, which is, well, actually two things today. You're going to learn about the commutative property of multiplication, and we're going to talk about how you can do a picture, or in math, we like to call it a pictorial model. But all that means, pictorial model, is to draw a picture that represents the word problem. This is probably my favorite strategy, a pictorial model, because when I get to those difficult word problems, it helps me to just draw what the problem is talking about. If it's talking about, I have three boxes of pizza and we cut it into 10 slices, and I'm totally confused, well, I'm just going to draw 3 pizzas with 10 slices in each to try to figure out the problem, okay? So drawing a picture, a pictorial model, is going to really be helpful when we get to those harder word problems, okay? So if you're looking at the board right now, first let's talk about the commutative property. We've talked about the commutative property of addition. Does anybody remember what that means? Of addition, it looked like this. If I said 5 plus 3 equals 8, and then I changed the numbers around, did it change my answer? No. It's still going to be 8, right? Okay, now the same thing is for multiplication. You can flip those numbers around, but it's not going to change your answer. Okay, so if I have, let's just use the example over here that's on this poster, my multiplication poster over here on the wall. It has 3 times 5. So 3 groups of, remember that's what we learned yesterday, the multiplication sign is where we say groups of 5. Okay, that's like saying 5, 10, 15, 3 5s. So I know that equals 15. Now if I flip the 5 and the 3 around, your answer does not change. You still have 15, but your groups may look different because now instead of 3 groups of 5, I'm going to have 5 groups of 3. Okay? So your groups might look different, but your answer will still be the same. Okay? All right, so now what we're going to do is we're going to look at some word problems. And I want you to practice again like what we did yesterday, drawing your groups and then doing the repeated addition. Okay? So let's look at the first one on the board. It says, how many legs are on 7 beetles? 7 beetles. Okay, so if I have 7 beetles, first we need to count the legs, right? 1, 2, 3, 4, 5, 6. So 7 groups of 6. Okay, so draw your picture to help you figure that out because those are big numbers. So you're going to have to count everything, right, to get your product. 7 groups of 6, and then as I'm walking around the room, I want you to do your repeated addition. Repeated addition is going to help you find your answer also. If you don't want to have to count all those dots, you can add everything up. Okay, so those of you at home could be doing this on your dry erase mat. You could also be doing it on a sheet of paper or in your math notebook. So all we're doing here is the groups and repeated addition, the same thing we did yesterday. So let's look at what your group should have looked like. 7 times 6 means 7 groups of 6, right? 3, 4, 5, 6, 7. Okay, and then how many should I put in each group? 6. Okay. Okay, now repeated addition. If I'm going to add all of this up, I see 6 plus 6 plus 6. And then another row with 3 groups, so 6 plus 6 plus 6. And then one more at the bottom. 7 sixes, right? So now I can either just start adding these up, or I can count all the dots. Whatever is easiest for you to get your answer. We're going to have to do that for now until you master your facts. That's why it's so much easier if you master those facts, because how many of you want to sit here and count all these dots right now? No, it's not very fun. So when you start to practice your facts, it makes you feel so much more confident, and it also makes your life a lot simpler without having to count all of this stuff, okay? So you could have counted the dots. We also could have added the sixes. So Gregory said he did 6 plus 6 is 12. Okay, so 12 plus 12 is 24. 24 plus this 12 would be 36. Plus one more 6 would be 42. Very good. So that is my, and what do we call this? Product. Okay. Now if I had 7 times 6 as my equation or my number sentence, how would I show the commutative property now? Kelsey. There you go. We just flip them around, right? Commutative property means I can flip these around and I still get 42. Okay, very good. Okay, let's go on to the next one. How many arms are on 4 octopi? Well, how many arms are on 1? 8. So now I don't just have 1, I have 4. So that equation would be what? Who can help me out? 4 octopi and 8 arms on each. How would I write my number sentence? Aaliyah? There you go. The only reason I say flip it around is because we're doing 4 groups, or 4 octopi, 4 animals, with 8 on each animal. That's your groups. Now, if we were to say 8 times 4, would it make my answer wrong? If Aaliyah had done 8 times 4 instead of 4 times 8, would she get the answer wrong? No, because we just learned commutative property. If I do it flip-flopped, it's still going to get the same answer. Okay, now I want to see you drawing your groups to solve for the product, and then do the repeated addition. Make sure your groups are nice and neat so you can count all your dots. And then make sure to also do repeated addition. So 4 times 8 means 4 groups of 8, right? And what did we get for our answer? 32. Very good. What would the repeated addition look like? 8 plus 8 plus 8. Just 4 of them, right? Good. Okay, and how many ears are on 9 rabbits? So what would my number sentence be for that? How many ears are on 9 rabbits? Good. 9 groups of 2. Oh, what happened here? There we go. 9 groups of 2 because there's 2 ears on each rabbit. Okay, and what did y'all get for your answer? 18. Very good. So I would add up what? 2 plus 2 8, 9. Good. Now I'm going to give you a little insight onto another multiplication strategy. Count by twos, Kaylee says. Good. We call it skip counting. So I'm going to skip count by twos, and I'm going to stop when I get to the 9th one. Okay, y'all are going to count with me. Ready? Go. 2, 4, 6, 8, 10, 12, 14, 16, 18. And I have 9 fingers up, so that means I have 9 groups of 2, which is 18. Okay, very good. So skip counting is another thing that we can do for multiplication. All right, let's go on to number 4. How many arms are on 8 starfish? 5 on the starfish. How many arms are on 8 starfish? So draw your groups and show your repeated addition. Now somebody said, oh, we can do skip counting on the next one too. What would we skip count by on this one? 5s. Very good. Okay, let's show our groups. Let me clear this. Clear ink from page. So we had 8 starfish, right? And 5 arms on each. So that's 8 groups of 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'm not going to draw the dots. Just this time I'm just going to put a 5 inside. Especially since I know I can count by 5s. Okay, now let's count together. Ready? 5, 10, 15, 20, 25, 30, 35, 40. I did 8 skips and I stopped at 40. So 40 is my what? What do we call this? What do we call 40? What do we call the 40? Starts with a P. Oh my goodness. Product. There we go. And what do we call the 8 and the 5? Starts with an F. Factors. Thank you. Now if I flip those around, what do we call this property? Commutative property. Okay? Commutative property means I can flip the numbers around and I'll still get the same answer. Okay. Repeated addition. 8 groups of 5, so I would have 8 5s. That's 3, 4, 5, 6, 7, 8. Okay? Any questions so far? So we've learned pictorial model, which is just drawing a picture. We've learned how to do skip counting today. We talked about skip counting. We've talked about how to do repeated addition and equal groups. We also now know commutative property. I can flip the numbers around and still get the same answer. Okay? Okay, 2 more. I want you to go ahead and do these last 2, and I'm going to come around and look at your boards and see if your groups and your repeated addition are correct. I'm also looking for the product to be correct. Okay? Number 5, I'm going to read it to you, and you're going to do it on your own. How many legs are on 7 cats? 7 cats. Well, 1 cat has 4 legs, so how many legs are on 7 cats? And then go on to number 6. How many horns are on 3 bison? Okay, so I'm looking for your groups, your repeated addition, and your product. Okay, so moving on to 5 and 6, checking them. I'm going to go ahead and write number 4. 8 times 5. 8 groups of 5, and we said that was 40. Moving on to number 5, how many legs are on 7 cats? So you should have had 7 groups of 4. 7 times 4, and what did we get, class? Very good. And if you flip-flopped it around, that's okay. That's the commutative property. You would have done 4 groups of 7. And so you could have added 4 plus 4 plus 4 plus 4, 7 times, right? 1, 2, 3, 4, 5, 6, 7. Okay, or you could have done it, if you did it this way, it would have been 4 sevens. 1, 2, 3, 4. Okay. And number 6, how many horns are on 3 bison? So 3 bison are your groups, right? It's a buffalo. It's like a buffalo. So 3 groups of 2. So you could have drawn 3 groups, 2 in each group. Can I skip count on this one? Yes, let's skip count. Skip count by 2s with me. Ready? 2, 4, 6. Okay, we stop there because we only have to do 3 groups. So 6 is our answer. What do we call the answer? A product. What do we call the 3 and the 2? Factors. What do we call the answer again? The product. Okay. In repeated addition, good. It would be 2 plus 2 plus 2. Very good, Evangeline. All right, so let's look at what they're doing in Seesaw today. So I see groups of cats, correct? Everybody see the different colors of cats. That's separating our groups. I have 1, 2, 3, 4, 5, 6, 7 pink, 7 green, 7 orange, 7 yellow, and 7 blue. So what would my multiplication sentence be? Anybody know? What would my multiplication sentence be? One, 2, 3, 4, 5. I have 5 groups. Okay, now let's do the repeated addition. What if I'm looking at my groups of cats? Am I going to add 5 plus 5 plus 5 plus 5 plus 5? No, because I don't see 5 cats here. I see how many? 7. So I'm going to add 7 plus 7 plus 7 plus 7 plus 7. Okay? Now, say I don't want to skip by 7s and I don't want to add 7s over and over again or count all of these individual cats. If I see a 5, I'm going to skip by 5s because I'm good at that. Okay? Don't make more work for yourself. Okay? Use that commutative property to help you. So instead of skip counting or adding 7 over and over again, I'm going to skip by 5s 7 times. Okay? So let's count by 5s. Stopping at the 7th one. Okay, ready? Everybody count with me. 5, 10, 15, 20, 25, 30, 35. So my answer would be 35. Now, how could I check to be sure? Make sure I didn't make a mistake and doing the flip-flop commutative property didn't actually mess me up. How could I check this? Evangeline? Count all the cats. Very good. So if I wanted to take the time and count all the cats, I would say that, okay, there's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Into the blue, that's 29, 30, 31, 32, 33, 34, 35. So I know my answer is correct, okay? All right, next one. Cars. Okay, on your mat, I want you to write the repeated addition and the multiplication sentence that you see represented by these groups of cars. Count by 2s. Why would we count by 2s? You see groups of 2? Okay, if I'm looking at these groups of cars, I see a blue set, so that's 1 group. A pink, that's 2. Green, 3 groups. Purple, 4 groups. So there's my groups. 4 groups of, how many were in each group? Evangeline? 7 again. Okay, good. So repeated addition would be 7 plus 7 plus 7 plus 7 equals how much? 28. Good. Okay. So you could have counted every single car or added up 7 plus 7 plus 7 plus 7. 28 is correct. Okay, 2 more. Repeated addition for the kites in the multiplication sentence for these kites. Let's look at the groups. How many groups do you see, Gregory? How many groups of kites? How many colors? 6 groups. 6 different colors, right? Lime green, pink, purple, that's 3. Yellow is 4. Orange is 5. Blue is 6. Okay? Now my second factor is how many are in each group. So now I need to look at the kites in one group and count them up. How many do you see in one group? 7 again. 6 times 7. So that means 6 groups of 7. 6 groups of 7. So what am I going to add up, Devea? What should I put in these boxes for repeated addition? 7. Good. So 7 plus 7. Well, let's think back to the one where we did 5 times 7. The first one, I believe. 5 times 7 we said was 35. So if I have one more group of 7, all I need to do is take 35 and add 7 more to it. So let's count starting from 35 and add 7 more. So that would be what? 36, 37, 38, 39, 40, 41, 42. Okay, so I just knew my 5 times 7 was 35. So I added one more group of 7 to make it 42. If you didn't do that, you could have just counted all of the kites, right? All right, last one. Last one. Who wants to tell me, or who wants to come up and show me? All right, Javea. This is the last one, and then we're going to go on to our assignment. So Javea is coming up to the board, and she's going to give me the number sentence for repeated addition and multiplication. So just watch Javea. She's thinking, she's counting. Good. Okay, for multiplication, how many groups are there? 2 groups. Good. Of what? 2 groups of 7. What would our product be? Okay, good job. 2 groups of 7 equals 14. Good job. All right, you guys at home, you will see the next 5, 6, and 7 slides. So the next 3 slides will be you making your own groups with the emoji stickers. And then you need to write the repeated addition sentence for it and the multiplication sentence for it. Okay, so 3 more slides. Making up your own problems, your own groups. So when you're building your groups, what is important, class? Can the groups be a group of 3 and a group of 8? Or how would I multiply that then? If I have a group of 3 and a group of 8, 2 groups of, they have to be equal, right? I can't do 2 times 3 and 2 times 8. That wouldn't be right. Okay, so your groups have to be equal. Okay, otherwise you're not multiplying, you're just adding. You're just adding 3 plus 8. Okay? So make sure when you do your groups, you have equal amounts in each one. Okay?